In question 4, we have to solve each of the given equations. So the equation in part A is 10p is equal to 100. So we will separate the variable p by dividing by 10 on both sides. So that is the step that we are going to carry out. So we have 10p is equal to 100, the original LHS and RHS, and we are dividing both sides by 10. Now on the LHS the 10s cancel out and we have 100 by 10 equal to 10, and this gives us p equal to 10. So the solution for equation A is p is equal to 10. I'm going to write it here with the question. Okay, now in part B the equation is 10p plus 10 equal to 100. So first we will get rid of this 10 by subtracting 10 on both sides. So the original LHS is 10p plus 10, the original RHS is 100, and we are going to subtract 10 on both sides. So minus 10 and minus 10. Now these 10s cancel out and on the RHS we have 100 minus 10, which is equal to 90. So we get 10p on the LHS and 90 on the RHS, but we have still not separated out p. To do that, we will now need to divide by 10 on both sides because we need to get rid of this 10. Okay, so let's do that. So we have 10p equal to 90 and we are dividing both of these LHS and RHS by 10. Okay, so the 10s cancel out on the LHS and 90 by 10 is 9. So we obtain p equal to 9. This is the solution of the equation in part B. Let's write it here. The solution is 9. In part C, the equation is p by 4 equal to 5. So we have this 4 in the denominator on the LHS. To get rid of this, we will multiply by 4 on both sides. So we have p by 4, the original LHS, equal to 5, the original RHS, and we are going to multiply both sides by 4. So on the LHS these 4's cancel out and on the RHS 5 into 4 is 20. So we obtain p is equal to 20. So the solution in part C is p is equal to 20. In part D now the equation is minus p by 3 is equal to 5. So first let's get rid of this 3 by multiplying by 3 on both sides. So the original LHS is minus p by 3, the original RHS is 5, and we will multiply by 3 on both sides. So on the LHS the 3's cancel out, on the RHS 5 into 3 is 15. So we get minus p is equal to 15. But what we need is the value of p. So now we can multiply by minus 1 on both sides. So let's do that. So we have minus p equal to 15 and I am going to multiply by minus 1 on both sides. So the LHS will become minus p into minus 1 will become p, and on the RHS I will get 15 into minus 1 or minus 15. So the solution in part D is that p is equal to minus 15. In part E, the equation is 3p by 4 is equal to 6. So first we'll get rid of this 4 in the denominator by multiplying by 4 on both sides. So we have 3p by 4 on the LHS and 6 on the RHS. We are going to multiply both of these by 4. So on the LHS the 4's cancel out and on the RHS we have 6 into 4, which is 24. So we get the equation 3p is equal to 24. Now from 3p we need to go to p. So we will divide by 3 on both sides this time. So we have 3p and we have 24 and we're going to divide both of these by 3. So this is what we get. On the LHS the 3's cancel out, on the RHS 24 by 3 is 8, and this gives us p is equal to 8. So the solution in part E is P is equal to 8. In part F, the equation is 3s is equal to minus 9. Now all we need to do to separate out the variable s is we need to divide by 3 on both sides. So let's do that. So we have 3s on the LHS, on the RHS we have minus 9, and we're going to divide both of these by 3. So on the LHS the 3's cancel out, and on the RHS minus 9 by 3 is minus 3. So we are left with s is equal to minus 3. So the solution in part F is minus s is equal to minus 3. In part G, the equation is 3s plus 12 is equal to 0. So first we'll get rid of this 12 by subtracting by 12 on both sides. So the original LHS is 3s plus 12. The original RHS is 0, and we will subtract 12 on both sides. So minus 12 and minus 12 like this. So on the LHS these terms cancel out. On the RHS we have 0 minus 12, which is equal to minus 12. So we get the equation 3s is equal to minus 12. Now we have to separate s. So to go from 3s to s, we will now need to divide by 3 on both sides. So let's do that. 3s is equal to minus 12 is our equation, and we will divide both sides by 3. So this is what we get. So the 3's here cancel out on the LHS. On the RHS we have minus 12 by 3 is minus 4. So we get s is equal to minus 4. So the solution in part G is that s is equal to minus 4. In part H, the equation is quite simple. 3s is equal to 0, and to separate out s we need to divide by 3 on both sides. So we have 3s is equal to 0, and we will divide both sides by 3. So 3s by 3 is equal to 0 by 3, and on the LHS the 3's cancel out, and 0 by 3 is actually just 0, because any 0 divided by any non-zero number is 0. So we get s is equal to 0. So the solution in part H is s is equal to 0. In part I, the equation is 2q is equal to 6. So to get rid of this 2 on the LHS, we will divide both sides by 2. So we have 2q is equal to 6, and we are dividing the LHS and the RHS, both of them, by 2. So on the LHS the 2's cancel out. On the RHS 6 by 2 is 3. So we get q is equal to 3. This is the solution in part I. Q is equal to 3. Now on to part J. In part J, the equation is 2q minus 6 is equal to 0. So first we will get rid of this minus 6 by adding plus 6 on both sides. Okay, so the original equation is 2q minus 6 on the LHS and 0 on the RHS, and we are going to add 6 on both sides like this. So on the LHS the minus 6 and plus 6 terms cancel out. On the RHS 0 plus 6 is 6. So we get 2q on the LHS and 6 on the RHS. Now we need to separate out q from 2q. So we will need to divide both sides by 2. So let's do that. So we have 2q and 6 on the RHS, and we have to divide both sides by 2. Okay, so on the LHS the 2's cancel out. On the RHS 6 by 2 is 3. So we are left with q is equal to 3. So the solution in part J is q is equal to 3. In part K, the equation is 2q plus 6 is equal to 0. So the only difference of this equation from the previous equation is instead of minus 6 we have plus 6. So first we will get rid of this plus 6 by subtracting 6 on both sides. So that's our first step. So we have 2q plus 6, the original LHS equal to 0, the original RHS, and we will subtract 6 from both sides. So on the LHS, we these 6 terms cancel out. On the RHS, 0 minus 6 is minus 6. So we get 2q is equal to minus 6. And now we need to separate out q from 2q. So we will need to divide by 2 on both sides. So let's do that. So we have 2q is equal to minus 6, and we will divide by 2 on both sides. So on the LHS, the 2's cancel out. On the RHS, we get minus 6 by 2 is minus 3. So we get the value for q as q is equal to minus 3. So the solution in part K is q is equal to minus 3. Finally, we will do part L now. In part L, the equation is 2q plus 6 is equal to 12. So to separate q, first we will subtract 6 on both sides because we need to get rid of this 6. Okay, so let's do that. So we have 2q plus 6 on the LHS. On the RHS, we have 12, and we will subtract 6 on both sides. So minus 6 and minus 6. So on the LHS, these 6 terms cancel out. On the RHS, we have 12 minus 6 is equal to 6. So we get the equation 2q is equal to 6. And now we have to get rid of this 2. So we will divide by 2 on both sides. So let's do that, and we get 2q equal to 6. Dividing by 2 on both sides, this is what we get. On the LHS, the 2's cancel out. On the RHS, 6 by 2 is 3. So we get the solution q is equal to 3. So the solution in part L is that q is equal to 3. And with this, we have completed all the parts of question number 4. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.